Okay, so our project is called DROVER. It stands for Drone-Rover Communication for Pathfinding. This is our team. Micah is not here, unfortunately, but yeah, talk a little about it.
Okay, so the main objective is to find a solution to how we can make a drone and a rover autonomously communicate to cooperate to pathfind in unknown areas. The drone and the rover will serve different functions, as the drone is what we call the global view, and the rover is the local view. The drone has clear view of the entire path and must calculate the shortest, most efficient path around long-term obstacles. The rover must communicate and follow these instructions while also locating and dealing with short-term obstacles at a closer view than the drone can see. Possible applications of this method could include reforestation, agriculture, rescue or delivery, trash collection, or even space exploration.
There are two big control problems that our system has to address in order to function. The first is multi-robot simultaneous localization and mapping, or SLAM for short, which is concerned with building a global map and keeping track of the robot's positions within that map over time. We don't have time to go into the depths of this algorithm and all the nonlinear estimation. What's important to know is that we plan to use an extended Kalman filter and 3 inputs into that filter, namely a 3D stereo vision setup on the rover, a 2D vision setup on the drone looking down, and a GPS and odometry to keep track of the relative states of both robots over time.
So the second problem involves allowing for effective cooperative pathfinding. And we approach this problem with the heuristic we dub LDSC, or long-term direction, short-term correction. And so the drone provides a long-term direction with its 2D bird's eye view of the landscape, while the rover handles short-term correction of that path using information from its more granular 3D view of its surroundings on the ground. So ultimately, these two work together to find like the optimal path through a series of obstacles. And most of the progress that we've done on designing this protocol has involved the 2D pathfinding, which Sam will go into now.
So essentially, this slide shows one of our first tests at implementing pathfinding. However, there are several key simplifications that make this unrealistic. First, it represents boundaries as absolute, rather than something that can be traversed with additional costs. To generate these images, we use the Dijkstra algorithm to find the shortest path on a graph, treating each pixel as a node on the graph with adjacent nodes as possible moves.
So by making the boundaries granular as opposed to absolute, the pathfinding algorithm no longer treats the detected edges as uncrossable paths, or obstacles rather. Instead, the calculated path is now based on the principle that changing color is more costly than staying on the same color. Changing color is more costly than staying on the same color, and it chooses the path from point A to B that induces the least cost. So as you can see on the bottom 2 photos, the algorithm chooses the path that follows the road because the road is the same color. In the left photo, the algorithm decides to cut through the grass because it determines that the cost of crossing the boundary is worth the added efficiency.
So there's a lot of work to do in this project, and we're going to continue tackling the pathfinding problem that we've discussed and that we've worked on mostly by adapting our scripts to real-time drone footage so that they can, make the paths in real time. Furthermore, we're going to keep on adapting or creating or working on the LDSC protocol, and also implementing EKF extended Kalman filter SLAM, and doing some real physical testing of the drone and rover. So really trying to put it together and get some physical results. So that is all. We hope you're interested in joining us. Thank you for listening.